Today we install the SKR version 1.3 32-bit mainboard. So we are going to install the SKR 1.3 Big Tree Tech mainboard on log today, but when you're going to 32-bit, there's a lot of things to consider as far as speed and kinematics of your 3D printer goes, and that's way too much information for just one video. So today I'm going to give you a primer on some of those subjects, but mainly we're going to be focused on the install of the SKR 1.3 and the features that it has. So there's a couple of reasons why you might want to pick this board. One, this one cost me less than $25 US, so it's very affordable if you want to give it a try. It is 32-bit, but it's also compatible with a lot of the smart stepper drivers like 2130s and 2208s. You don't have to mess with the jumpers any longer to get their benefits. You can just use the pins on the board and it's all integrated right in for UART and SPI. So we definitely want to check that out. So let's go through a couple of different scenarios so I can show you some of the different things that I'm talking about. First, we're going to do ramps with A4988s. We'll take a listen and see what it does. Then we're going to go to ramps and 2208s and check that out. Then we'll jump to SKR 1.3 with 2208s out of standalone mode in UART mode so I can show you those features that are directly baked onto the board. So let's get started with ramps and some A4988s. This is log printing a test circle at 60 millimeters a second, and there's a couple of things to note. It is kind of noisy, but it's not having any problems processing that G-code. It's coming directly from the SD card. That will be important for later videos, and all the speed options have been turned off, including cooling, which might slow things down, as well as advanced acceleration in the slicer, and linear advance is off. So that's 60 millimeters a second. This is log at 100 millimeters a second printing our test circle. Again, it's coming from the SD card, and this is a true 100 millimeters a second. All options have been turned off. You can see it's very noisy, but also it's starting to stutter. It's struggling to process that G-code. And this is log at 150 millimeters a second. Again, the same setup on the G-code. We are coming from the SD card. It's very noisy, but it's really struggling to process that G-code. It's important to mention that the G-code I'm using for these tests is just for testing. You're never going to want to print at this speed, and the slicer settings that slow your print speed down are there to give you a higher quality print. I tried to get as close to the millimeters a second speed that I'm telling you, with acceleration and jerk values applied by the firmware. You're not going to be able to achieve the print speeds on a Cartesian i3 machine more than likely to be able to max out that 8-bit processor like we did in these tests. With that said, let's move on to some 2208s. Now this is one of the more affordable versions of the 2208 removable driver. And the 2208 can be configured differently based on the board that it comes on. And if we take a look at the underside of this board, you'll see that we have a couple of different sets of solder pads that we can solder up to change the aspects of this board. We're mainly interested in these three right here. These boards by default are configured to be in standalone mode, so that's going to be in Stealth Chop, the quiet mode, and they're a direct drop-in replacement for something like an A4988. There's very little you have to do to be able to use these drivers. And on the water rot 2208s, you're going to have pretty much the same kind of configuration. They do a little better job of separating the badging for the UART power down and the MSI 1 and 2 pins. Same kind of thing. The potentiometer for adjusting the voltage in standalone mode is going to actually be on the other side, but you can get to it from the top. And on the newer versions, I have been seeing the same 3 pads, just like on the other manufacturers' boards. These are for setting from standalone to UART mode. So these should be configured for standalone mode by default as well. And in standalone mode on that type of driver board, you're going to use these jumpers on your board, at least on the ramps board, to configure the stepping for that driver. So for example, for the X driver, we have MS1, MS2, and MS3 jumpers. The MS3 jumper is actually not used by the 2208, and if you leave that on, one of those pins is going to be set to high. Now, I don't know if this is an actual concern for the 2208, especially for this type of board, the one that's pre-configured for standalone. I don't think it matters a whole lot because that's usually the UART pin or the power down pin. But it's probably best practice to go ahead and remove all the MS3 jumpers for all the ones you're going to use the 2208 on. So you're going to want to take that one off and leave it in this configuration. That's going to set you to 16 times microstepping standalone mode for your 2208. And when you install your 2208 on your board, it's very important that the pins line up correctly. On one side, you're going to have direction and ground across from each other. On the ramps board, it's these two pins right here for the X. And on your 2208, you can see direction and ground pins right here. So it'll line up just like that. And in Marlin, really all you have to change is the motor direction to use a 2208, because it does go in the opposite direction as an A4988. You could also just swap the motor cables to get this same effect, but we'll go ahead and change it to Marlin since we're in here. So anything that is true on these invert directions, just set it to false, and vice versa. So we'll go false, false, true. And then extruder direction, change it to true. And there is one more setting in here for standalone mode 2208, and that's in the stepper driver type section. They're all set to A4988 now. I believe that is default even if these are commented out. And it probably doesn't make much difference to set these to TMC2208 standalone mode. But since we're already in here, it's probably best practice even for just documentation. So we're going to go ahead and copy that, and we'll just paste it anywhere we have A4988. Like so. And then we can re-upload to the board. It's important to note that this firmware is configured for my 3D printer. All I'm changing is stepper direction and the stepper driver type settings. And this is 60 millimeters a second with our 2208s. It has quieted down a lot. Log is not made with the most high quality parts, so it is kind of a noisy machine mechanically, but the stepper noise has really gone down. This again is still the raw G code. And this is 100 millimeters a second. It is quieter, but we're not going to have any effect over the processing of that G code. It is halting just a bit, trying to keep up. And here's 150. The 2208s aren't helping out a lot with the noise at 150 millimeters a second, and you can definitely see it continue to struggle processing the G code. So there's the G-code testing on ramps with the A4988s and the 2208s on the 8-bit board. Now this isn't going to be so important for this video, but it'll make more sense in future videos that you've seen the 8-bit test versus a 32-bit test. So let's move on and we'll get the SKR installed. So here's the board we're working with, and one of the first things we're going to have to tackle is we only have one Z plug, so we'll have to make an adapter that wires out to both our Z motors. You can see all these different jumper pins. This is how you configure SPI or UART mode out here, or your standalone mode. You can do it the same way MS1, 2, and 3. This does have an LPC1768 processor, and it is fully supported in Marlin 2.0. It has dual extruder support. There's a lot of open pins, including all your AUX1 pins, your SD card reader. It does have a 10 and 20 amp blade fuse. A little better style connector for your heated bed and your power in. As usual, your MOSFETs, your LCD connector is baked on board. All the min and max in-stop pins are available, as well as a couple of others to support a couple of different devices. 12 and 24 volt are acceptable on this board. So this board came configured with all these jumpers on by default. These are actually controlling SPI in this position. So the first thing we're going to do is remove all of these jumpers, and we're going to configure it for standalone mode for 2208s first. So all the jumpers are off, and if you short out these two pins, these should function the same as MSI 1, 2, and 3. And for standalone mode for the 2208, all we need to do is short out 1 and 2. So we'll put a jumper on these two sets of pins all the way down for all 4 drivers. So we've got all our jumpers set for standalone mode, and it's probably also important to mention that these jumpers over here, these are the diag pins, like if you're using a 2130 for SPI mode. Go ahead and remove those too. That's good practice. We'll just take those off. And we should be ready to go for 2208s in standalone mode. And we'll go ahead and put our 2208s on. Remember to line up the pins, direction and ground. They're going to go to these back pins here, just like this. And if I didn't mention it before, since you're in standalone mode, if you need to adjust voltage, you can use the potentiometer. We'll throw a water driver on Z just for fun. And now all our 22.8s are in, we should be ready to go in standalone mode. Now we can go ahead and cable everything else up. So to start the wiring process, I made a Y adapter for my Z motors. It only has one Z plug, so I just put those out in parallel with this Y adapter. One plug to two plugs, and these can go to my existing motor cables. So there's all my motor cables brought over from ramps. We've got X, Y, the two Z motors in my Y adapter, and the extruder. I tried to keep the wiring configuration exactly like it was for ramps, so I don't flip the motor cables over. Then there's all our in stops. I've got my probe on Z min, brown's positive, black is signal. And then I've got the in stop on the PCB for my Y, positive, ground in the center, signal is green. And then I have a micro switch for my X in stop, so I just use signal and ground, those two pins. And then I've got my thermistors plugged in right back here. We're using the center one for E0, and then the bed over on this side. Go ahead and plug in the LCD while I'm over here. EXP1, EXP2. Go ahead and hook up our hot end heater, like so. Our heated bed right there. And I'm hooking mine up to 12 volt, and it'll go right here. Power's hooked up. Now all we have left to do is the fans. And for our part fan, we're going to put it right here. This is controllable. So make sure you have negative and positive correct, like that. And for our hot end fan, we're just going to put it in right over here. This one is always on, so the hot end fan's always going to be spinning. You probably could use your second extruder hookup if you want to configure that in pins later. But for now, we'll just use this one. And make sure you have it set up correctly, right like that. And my extremely messy wiring job is now complete. So the wiring's done. Let's go ahead and power on just to see what happens. Make sure no smoke comes out. Fans come on, that's a good sign. It does boot into Marlin 2.0. So it has the second extruder set up automatically because the thermistor's listed there. So if you have two extruders, it's going to go extruder 1, extruder 2, and then bed down here. We don't have a thermistor plugged in for that, so the thermistor for the extruder looks good, and for the bed, roughly close enough. Now this is just a generic config, and if you switched around enough cables and flipped the motor cables over, you might be able to deal with this, but more than likely you're going to have to set up a brand new config anyway. So we're going to walk through those steps. So when you plug your mainboard into your computer, it's probably going to recognize it as a USB drive, and mine did. That's a good sign. You can see this firmware file. And if it doesn't, you're probably going to need a different driver for Windows. A lot of the vendors have those drivers on their site, so you might check with your vendor. Now Big Tree does give you a version of Marlin that they've configured for this board. I'm guessing the one that's already installed on here. But they do give you some information on how to use Platform I/O to update that config. I already have an install of Atom and Platform I/O that I like to use, so we're going to use that. But there are some instructions out here if you need them. And we're also going to start with a fresh copy of Bugfix 2.0 and configure it from scratch. You can download that from the Marlin site. A quick recap before we dive into the config. We swapped out our ramps board with our SKR 1.3. Everything appears to be working. I haven't made any movements yet, but we'll do that as we do the configuration. It does have Marlin 2.0 bug fix on it by default, something that's been configured for this board, but I would rather configure it from scratch for this printer. If you need to know how to get set up to configure Marlin 2.0, there is a video up here, and I'll leave more information in the description. So now, let's start the configuration. So our download of Marlin is complete. Let's head to Downloads. We'll extract all. And let's change the name of the folder to Marlin 2.0 _ SKR _ 1.3, just so we know the version we're working with, and we'll extract. Everything's been extracted. Now we're going to head into Atom because that's my preferred editor. There are a couple of others out there that you could use, but I like Atom. And Atom's going to allow us to use the Platform I/O IDE and edit our configuration files so we can compile everything and get it over to our board. Atom and Platform I/O just seem to work better for the 2.0 32-bit stuff. So let's start a new project. We'll go ahead and remove this project folder, the one I was working on previously. Right-click Add Project Folder. We'll go find that fresh download of 2.0. Here's our SKR. And we'll select the folder inside our SKR 1.3 folder. And this will bring the tree in of everything we need for the project. If you expand Marlin, you should see your configuration.h and _adv.h right here. And the first thing I like to do is come down here and edit the platform IO init file. And at the top of the file, our default environment variable, most of the time it defaults to a 2560. We're going to switch it over to LPC 1768 because that's the kind of processor we're dealing with on this board. And we can go ahead and save our platform IO init file. We'll just go File, Save. Now we can start the Marlin config. Let's go to configuration.h. Let's go ahead and change the name. We'll do Chris Riley SKR 1.3 config. We'll leave serial port 0 for now. Sometimes you have to set it to -1, but we'll try it this way. We'll leave baud rate at 250,000. And now we need to update the board name. The easiest way to find your board, we'll go over here to the source folder. We'll go into core, and we'll open up boards.h. And we'll scroll down. And we have a big tree SKR 1_3. We'll just copy that line, back to configuration.h, and we'll replace the motherboard name with that entry. We'll keep on scrolling. We have one extruder. We want to use 1.75 filament. It's just good practice to change that. No multiplexing, no auto power control. On my thermistors, both are set to 1 for the extruder 0 and the bed temp sensor. For now, all these default settings are fine except max temp on the extruder. I'm going to set that to 255 and the bed 110. PID is something we can come back and tune later. We'll leave it default for now. Same with the bed PID tuning. Thermal protection is in place. End stop settings should be fine. We're going to go with the settings I have from the other config for the inverting. And my X-min is false. My Y is true. My Z is true. I'm using an NPN sensor. And if your Z changes, your Z minimum probe in stop has to change as well, so true. To start the config, we're going to do 2208 standalones. So we'll go ahead and update these for the 4 motors we have, like so. Come down to movement. My X and Y are 100. Again, all this information is coming from my previous config. My Z is 400, and my E is around 130. That can be configured and calibrated later. And for this testing, I have my feed rate and acceleration set really high. You don't want to set yours this high if you're planning on printing nice prints on your printer. So my suggestion, leave them default unless you have a problem, come in and tweak them later. But I'm going to return mine to the settings I was using. So 3000 for X, 3000 for Y. I have 3 on Z since it doesn't matter that much, and 1000 for the extruder. And my default Excel, 9000 for X, 9000 for Y. We'll leave Z alone, and 10,000 for extruder. And then default acceleration, 9000, retract 9000, travel 9000. Again, don't use these values unless you're testing like I am. We'll leave junction deviation alone. Since it is disabled, here's the jerk values. I'm going to leave those stock for now. Again, another thing that you can leave default until you need to adjust it. And then we come to the Z probe settings. I do have a Z probe, so we want to make sure that Z minimum in-stop pin is being used because that's the pin we're using. My probe type is a fixed mounted probe. My probe location is to the right and to the back of the nozzle. So we're going to do a 23 on the X and a 10 on the Y. And my offset is roughly -0.8. Again, another option you can calibrate later. I don't use minimum probe edge, so I'm going to set that to 0. We can leave the homing feed rates to default. We need to adjust the motor direction just like we did before based on the drivers that we're using. So my X was set to false, Y needs to be false, and my Z was true. My E0 was also true. Again, this has the same effect as flipping the motor cable. We'll adjust the bed size. Mine's 250, 220. My Y minimum position is actually -2 because my nozzle's a bit in front of the bed when it homes. Z max is 210. We'll leave minimum and maximum software end stops enabled. I'm not going to set up filament runout now. Then we'll come to bed leveling. I'm going to use bilinear. All this is default. We'll leave it at 3 grid points. But I do have to hit certain points to be able to use that Mark 42 bed. So we're going to edit these. I'll uncomment all 4 of these. And this was just trial and error and with a ruler to be able to get these spots correct. But my left position is 35. My right position is 240.5. My front is 19.5. And my back is 216. Again, a very specific setting for your printer. You might have to play around with that. I do define Z-safe homing, but most of the time Z-safe homing will get you in the center of the bed. You can see it's dividing the bed size by 2. That should be the center X and Y. I actually use it to hit the point that's on the corner of my bed because it's set in just a little bit. So instead of these values, I use X 35 and Y 19.5. That puts the probe in the exact spot that I need it to home. Homing feed rates are fine at default. We won't set up skew correction. We can go ahead and enable EEPROM, just take that off. We can update our preheat settings. PLA, I like 215 and 60 on the bed. ABS, 250 and 100 on the bed. Nozzle park, I'll go ahead and leave that on for now so I don't have to set it up. No nozzle clean. And then we come down to the LCD section. We want English. We'll keep it classic, so we're going to do LCD info screen style to 0. We want SD support. This is the SD card that's on the LCD screen, by the way, not the one that's on the board. We'll leave most of this commented out for now. We can come and tweak it later. We'll go ahead and define the speaker, and we'll uncomment RipRap Discount Smart Controller, because that's the 2004 display that we have. And everything else in here can stay default, but I did miss one setting, and that's all the way back to the top. And that's my custom machine name. Definitely have to change that. We'll do log SKR 1.3. Looks good. Let's go ahead and save that configuration file. File, save. And in configuration_adv.h, there's nothing I want to change at the moment, but we will have to tweak it when we go to UART mode for the 2208s. So for now, let's go ahead and build this and see if it works. So if you hit the check mark, this will do a build. It's just like a verify in the Arduino IDE, just to check and make sure everything's going to work. We did have success, but if you want to see that again, come back up here to Platform I/O, and we'll toggle Build Panel. You can also hit F8 if you'd like. But you see we had success, and if you scroll up a little bit, we had success on LPC1768. That's what we want to see. Now we can upload it to the board. So we're plugged in USB, and the printer is on, and there is an SD card in the board slot. And if you remember before, we've got our USB drive right here. This is when we plugged the board in. It came up as a USB drive. That's the firmware file. And if we go back to Atom and hit the arrow, that's upload, it should find our device by default and go ahead and upload the code. Let's give it a try. Upload disk I. It did find our device, and the upload's complete. That window closed. Let's go ahead and toggle it back on. We had success. Took 4.14 seconds. Go back to iDrive. And we have our new firmware bin file. Now if we reboot the printer, our USB drive goes away, we'll turn it back on, our USB drive's back, and our firmware has been updated with the date and time. And no matter if you've turned the printer on and off or not, after you make a configuration change, turn the printer on and then hit this reset button. This will just make sure that everything is clear and the board's reset, ready to use that new code. And our name for our printer's been updated, so that's a good sign. We only have the 2 thermistors now, one for the hot end, one for the bed. So let's go ahead and do some tests, make sure everything looks good. We'll open up Printerface. My board is on COM port 22. We'll go ahead and connect. And Printerface failed to connect, but that's okay. That's probably that serial setting that I talked about before. We need to set that to a -1. So let's jump back to Atom, configuration.h, pretty much all the way back to the top, serial port. We'll set that to -1. And let's go ahead and re-upload. If you forget to save the build, it will ask you if you want to save. Yes, we want to save and build. And our build was once again successful, and our upload was completed. Again, we made a configuration change. Let's go ahead and hit reset. Now let's go ahead and try Printerface again. Let's open it back up. We're still on COM 22, 250,000. Let's hit connect. And with that fixed to the -1 on the serial port, we can now connect. So that's good. We'll go ahead and set to 215 and 260 to check the temps. Let's do some Z up. Make sure the motors are working. They are. How about some X? Looks good. How about some Y? Looks good. Let's go ahead and auto home. And we have auto home successfully. And since the hot end's up to temp, let's go ahead and hit extrude and make sure it's turning the right way. And it is. So for a base config in standalone mode, we should be in pretty good shape. Now let's run our tests again on the new 32-bit board with the 2208s in standalone mode. 60 millimeters a second, no issue there, of course. 100 millimeters a second, no worries. If you see it stutter a little bit, that's because it's jumping to the next layer. It's a circle that has 3 lines, an outer, an inner, and a center. So it's actually violently jumping to the next layer. But there's no stutter from lack of G-code like you saw on the 8-bit board. Same thing with 100 millimeters a second. This is 150 millimeters a second. You can see it stutter when it jumps the next layer up because it takes a second, but there's no stutter caused by lack of G-code like we saw on 8-bit. It is moving. So there's our testing, and it's pretty obvious that you can process G-code faster on a 32-bit board. And you should be able to print faster if your hardware can support it. And I only ran into one issue while I was installing the board, and that's with the pin connectors. Log has DuPont type connectors on all the wires, and sometimes when I'm testing boards I can get by with parking those DuPont connectors in a JST type connector, but not on this one. They're just a little too short. I actually removed some of the plastic JST connectors so I could use the bare pins, but you don't want to do that. So make sure you're using JST connectors on your printer before you try to install this board. Now this video is getting pretty long, but there's one more thing I wanted to test, and that's the 2208 in UART mode. And there's a few things you have to do to get set up to do that, so let's get that done now. So you remember our 2208 driver from before? We have these 3 solder pads right here. Well, we need to connect all 3 of those pads to be able to use UART mode. So we'll take it from this to this. We connected all 3 of those solder pads right there together. And be careful when you're doing this. This is really small work and really close to that chip. But that should be the only thing we have to do to the driver to be able to use UART mode with the SKR 1.3. Now on the board side, to use UART, we should be able to remove these 2 jumpers that we used for standalone, and then we'll short out this red jumper right here, and that should turn UART on. So the standalone jumpers have been removed, and the UART jumper has been installed right there. Then we can put our freshly soldered driver right back on. Now we'll make some Marlin config changes. So back into Marlin, we want to scroll down to those driver settings that we were looking at before. We changed them to 2208 standalone right here, and we just swapped the extruder driver to 2208 UART mode. So we're just going to take off the standalone and the underscore for that driver. That should be all we have to change in configuration.h. Let's go take a look at configuration_adv.h, and let's just search Control F for Trinamic. That'll take us down to the stepper driver section. So the first one you come to is 2600s. We don't have those. And then we'll come down to the Has Trinamic setting. This should cover 2130s and 2208s. And all this should be set up by default. It should be controlled by the configuration.h setting. But we'll take a look at E0, this one right here. And these are the default settings. 800, 16 times microstepping. This is just fine. This is a test just to make sure that the board is working and you're able to use UART mode with just that jumper setting and the soldering patch. So if we scroll down a little more, this will give you all the default settings. So we're using Stealth Chop for X, Y, Z, and E. That's fine. It allows you to set chopper timing. It allows you to monitor driver status. That could be interesting. Let's go ahead and uncomment that. You can switch the hybrid threshold. That's where you use Stealth Chop and Spread Cycle as demands increase. Centerless homing, that's only on the 2130. Here's your debug setting. Let's go ahead and turn that on, just so we can see what's going on with the driver. And your advanced setting is down here. That's enabled by default. But in your debug, that's going to give you the command that you can use to see what that driver is doing. So M122. So that should be all we have to change to use UART mode for the 2208. So let's go ahead and re-upload. The upload was successful, and like I said before, anytime you upload code to a 32-bit board, it's a good idea to turn the printer off, then turn it back on, and hit that reset button on the board, just to make sure all the code changes come in. Now let's jump to Prime Face. We'll connect up. You can see the first time it came up, it tested the E connection OK. That's a great sign. Let's go ahead and set our hot end temp so we can test the extruder. While we're waiting for that to heat up, we can do our M122 command to see what our status is. No temp warnings. Everything looks really good. Current 800. When you don't see any Fs down here in the driver register, that's also exciting. That means things are working great. You can use the M906 to see what current voltages are. It's at 800. If you wanted to turn the voltage up on that extruder, you just do E and the voltage you wanted to turn it up to. Let's turn it up to 850. 906 to see what it is again. It's at 850. Now we're up to temp. Let's go ahead and do a test extrude. The motor is turning. Go ahead and do an M122 to see our status again. It's enabled. That means it's in use. Our current was updated. Everything looks great. And there we go. Our SKR 1.3 board is installed, and we're using 2208s with the native UART connection. That saves you a lot of work from connecting up wires and resistors to be able to use all those features. Now again, there is a lot we could do with this video. This video has been long enough, but I will break out into other videos on things you could do with this SKR board, and maybe some different configurations and speed tests. I hope you found this video helpful. If you did, please consider giving it a thumbs up or subscribe to my channel. If not, leave your thoughts in the comments below. And as always, thanks for watching. Ludicrous speed!